In this video, which is standard to vertex form part 3, I'll show you how to convert the standard form of a quadratic equation over to the vertex form, but I'll show you both ways on the same particular equation. So first things first, let's look at what we have been basically doing for complete the square. And that was to take our quadratic and set it equal to 0. And then we would take our constant and move it to the other side. That would give us negative 4x squared minus 8x equals to 4. Now, at this point, we would need to factor out the negative 4 from the quadratic term and the linear. So that would leave this. If we factor out, that'd be a positive 2x. And then equals 4 plus negative 4 times whatever we have right here. So let's look at what we will have. Now we can complete the square because that's a coefficient of 1 now. Half of 2 is 1. We're going to square it, so that'll be plus 1. Here's your plus, and here's 1. Now, we can write the perfect square trinomial. X plus 1 squared equals, that's 4 plus negative 4. Okay? 4 plus negative 4, or negative 4 times 1 is negative 4, so that becomes 0. So that is 0. And if I had to move 0 over to the other side, it really wouldn't matter. So that means our k is 0. So that leaves us y equals to negative 4 x plus 1 squared. And we know that our vertex, since we're going ahead and pulling our vertex out anyway, just to get in extra practice of what vertex form really allows us to do, is that's a positive 1, so therefore it must be a negative 1, comma 0. There's no k, so the k is 0. Now, let's do this problem again, but let's do it with everything on one side. So we have y equals negative 4x squared minus 8x. We're going to take this constant, we're going to move it way out here. Now, again, we're going to factor out the negative 4 from the linear and quadratic term, and we already have the negative 4 here. Now, what we're going to do is when we add whatever we get here to make the perfect square trinomial, well, half of 2 is positive 1, so we're going to square that. We're going to add 1. If we're going to add 1 over here, we're going to subtract 1. But that 1 is just not a 1 by itself. That is a negative 4 being put right there. Now, what we end up getting is y equals negative 4 x plus 1 squared. Well, this right here is negative 4. A negative makes a positive, so it's positive 4 times 1. We know that that is 0. So I could put plus 0, but I don't really need to. So y equals negative 4 x plus 1 squared. And we know that the vertex is negative 1, 0. Now, let's look at another example. Let's pop out of singles and go, or doubles and go to single page. Let's look at this particular example. We need to take it into quadratic form. Well, 4x squared minus 2. What you have to understand is because it has no linear term, there's no linear term. What I mean by linear term, that's an x to a first power. Then the quadratic is already in vertex form. Okay, so the answer would be exactly what you started out with. Y equals 4x squared minus 2. Well, the reason that works is this: 4 times x minus 0 squared minus 2. And we know that h and k, so we're going to do the vertex, right, If there's nothing in here, then the h value, I should say, is 0, and the k value is -2. Note that the h value is the only value that switches signs when being pulled out or put back in. But if you ever have a quadratic that does not have a linear term, then it's already in vertex form. So it's in both forms at one time.